A function to find its domain, right? What was it?
3 over f of x is f of x is 3 over x squared minus 2x minus 1.
Very good.
What is the domain of the function?
All right. So first of all, we have to factor or solve. If you remember, I mean, all we have to write is this, because the denominator cannot be 0. It's a rational function. So if you factor it or use the quadratic formula, you'll still get this. So there are two options. We cannot have 12 and we cannot have negative 10. And because of that, the domain will be from negative infinity to negative 10 union, from negative 10 to 12 union, from 12 to infinity. That's all we needed to do for this.
Well, okay, negative, okay, I know the boundary from the beginning to the end. It says minus infinity to the bottom minus 10, right?
Mm-hmm.
You don't know nothing. Okay.
Now the next function was
It says g of x equals square x minus 5 over.
Thank you for coming, guys. Over.
Over 8 over x minus 8.
Good. So this function, we are working on a couple of functions problems from the previous handout. Just for a minute. So this function is a different situation, right? It's a ratio, first of all, of two functions. And there are two potential problems here. One potential problem is division by 0. So that is obvious. I have to write that x minus 8 does not equal 0. Now, remember the square root. When we graph the square root, it looked like this. So this is the square root of x, which requires x greater than or equal to 0. We graph these functions in transformations a lot. Where does this function go? Knowing that this is the square root of x, where does this one go? When we change x into x minus 5.
X is greater than or equal to 0.
X minus 5 greater than, yes. But if we use transformations, just to recall that. So this is the square root of x, and how will I graph the square root of x minus 5? When I change x into x minus 5, where does the function go? To the right. It's x minus 5.
Minus 5 goes
So
right.
yes, so that's why it's very clear that the domain of this function starts at 5, right? So always remember that. You can always think in terms of transformations for these simple functions. You cannot use transformations on something like this. This is way too complicated. We don't know how to do that, right? But transformations on the square root of x minus 5, I do know because I know the base function, and this has to be shifted to the right. So that's another, if you want, reminder that the square root is not defined everywhere, and you have to write the quantity under the square root to be greater than or equal to 0. Not the square root. The quantity under the square root must be greater than or equal to 0. So these are the two conditions that have to be stated for this function. When I solve x minus 5 greater than or equal to 0, I get this. When I solve this, I get x not equal 8. So now on the real line, you don't have to graph. Remember, I graph it because it's easier for me to explain. So greater than or equal to 5, let's say it's this, but not 8. Not 8. So how do I write this in interval notation?
Bracket 5, comma, 8, parenthesis, union, 8, comma, 10.
So this is the domain of this function. Anything else that you would like to go back to? Anything else? And then I have a couple of few problems in mind to work on.
What about this one? Number 4.
Okay, what does it say?
Number 4.
Okay, we want to decompose. Very good. So let's use a different one. Because I don't want the other three to be bored. So let's say f of x equals 1 divided by the square root of x minus 3. Create an inner and an outer. There's more than one correct answer. And basically there are more than 3 functions in this. So just choose what you want. Just give me an inner and say, I will evaluate this function first, and once I'm done with this, I will evaluate this one. And you can call them the way you like. That's it. That will be one option for the inner. Once I'm done with that and I get one number, what will be the next function I apply to this number?
1. That's the outer.
So this is the function that I get a number for. Now, which function I apply now to this number? Which function is this? 1 over x. Right? Once I evaluate the square root of x minus 3 and I get 5, which function I apply to 5 is 1 over 5. Is that better? Okay. Good. Exactly the same. You have the inner, which is x to the 7th minus, yeah, and the outer will be the 6th root of x. Exactly the same. Is there anything else that you worked on that you would like to go back to before I make up my own? Anything that you looked at, anything that you worked on, anything that you would like to go back to and say, I want a problem like that?
My biggest problem is
Yes?
finding G of F. I
Yes.
can find F of G, but for
Yes,
some reason
yes,
my mind's
yes.
not
That's
working with G
a
of
very
F.
good, because a problem like this will be on the test. There is no secret about it. Yes. Okay. So give us any F, any G, whatever you want.
Oh, yeah, I do. Okay, x plus square root of x plus 9 minus.
Which one? Which one is? You're giving us
Oh,
F?
I'm sorry. Fx is equal to the square root of x plus 9, and gx is equal to the square root of x minus 3.
Perfect. And what do we want to find? The sum difference product ratio or function composition? I doubt that they are asking about the function composition for this, but it's possible. Are they asking us to find the sum difference product?
Yeah, yes, the sum difference.
Yeah, because this is a little bit beyond the scope of the course to find a function composition for these two radicals.
Then I'll ask you for an.
Oh, we can do this. We can do just, let's do one of them.
Okay.
Which one? Product, ratio, sum, difference.
I would rather do the.
Since we have them, just choose
the
one.
Product ratio.
The product and ratio, perfect. So let's say we want to find FG. Please always write the definition first, f of x multiplied by g of x, because this is what we are asked. This is the product of the two functions. I copy the square root of x plus 9, and I copy the square root of x minus 3. You do not have to do anything else here. Yes, you can multiply them and distribute. Inside, you can't do that because you can multiply. I can change a product. I can change the square root of a times the square root of b into the square root of ab. I am allowed to do that, and vice versa, back and forth. So I can say x squared, and this is minus 3x plus 9x is 6x and minus 27. I can do that. I'm fine with both. The ratio, f over g of x, will be by definition f of x over g of x, and the numerator is the square root of x plus 9, the denominator is the square root of x minus 3. Now, if the problem is asking us, welcome. If the problem is asking us to find the domain of these functions, then we have to start from scratch and determine the domain of f, determine the domain of g, welcome, determine the common domain. So let me know if we need to do that. Or we move on to function composition. It's up to you. You
Maybe the
decide.
domain of that one,
Which one?
the f over g.
Okay, in order to find the domain of this, I have to find the common domain first.
Oh, okay.
That's what I was saying.
Yeah.
So if we are asked to find the domain of any of these, if you remember, whenever we are asked to find the sum, difference, product, and ratio, we have to determine the common domain. And then after that, determine the domain of the ratio. Because normally here I would say, oh, just x minus 3 not equal 0. But no, that's not sufficient. So if we want to determine that, let's go back to the domain of f. So f of x equals the square root of x plus 9. Remember, in terms of the square root, remember the graph of the square root, remember where this is going, and you will find the domain of this. Or you remember that you have to write what? In order to find the domain of this function, what do I have to write and solve? Yes. So for some reason, I'm not sure, only very few people remember this. No one really likes the square root. I don't know why. No one really likes it. Right? Is it clear? Don't I have to move this graph to the left, 9?
Yes.
So that's why this comes into play, right? X greater equal to negative 9, and I know that. So the domain of this function is negative 9 to infinity. Now for function g of x, I have the square root of x minus 3. Think in terms of where it's moving. If you don't want to remember x minus 3 for some reason, greater than or equal to 0. We all have our hang-ups, right? I have certain things that for some reason my brain doesn't remember, right? So this may be one of them for some of you, which is fine. But remember where it's moving right now, right? Remember from transformations, if it's moving to the right 3, then it starts at 3. So that's exactly what this means. So then the domain of, so this was f and this is g. So 3 to infinity. Now I have to find the common domain. So we don't have to graph, but remember it's most of the time is easier for me to explain if I graph. So the first domain is negative 9. No need for units. This is just to help us understand what's happening. And the other one is 3 to infinity. The common domain I'm looking for, because if both functions exist, I can find the sum difference product ratio. But if they don't exist at the same time, there is no point. So the common domain must be where both territories are together, right? So if I pick a point here, no function exists. If I pick a point here, only one of them exists. So if I want to ask you to evaluate any of the functions, sum, difference, product, ratio, I have to, thank you for coming, I have to pick a point here and ask you to evaluate it here. So the common domain is 3 to infinity. Now coming back here, the only problem is x not equal 3, because now these two functions exist at the same time on this territory. So to find the domain of the ratio, I have to only exclude 3 from the common domain. So I determine the domain where they both exist, which is this, but now one of them is in the denominator. So this cannot be 0. Remember, we can create the ratio only if g of x is not 0. If g of x is 0, we can no longer create the ratio. So there is only one point, x equals 3. That's what I have to exclude. So the domain of the ratio is 3 to infinity. Okay. Is this better? Okay, perfect. Now, I would like to work on the function composition that you were saying. Just choose any two functions you want. Let's choose a quadratic and a linear. Or if you have something else for us, Wendy, just give it to me.
Fx equals 1 minus x, and gx equals 3x squared plus x plus 4.
Perfect. Which one do we want to determine? Or what if we determine both? Let's determine both. See, here's what I would do on scratch paper for this problem. I will make myself a note. This is my first note. And this is my second note. Meaning, this is what these functions tell me. The first one tells me 1 minus whatever you want. The second one says to me 3 times whatever you want squared plus whatever plus 4. Once I have this embedded in my head, I will be able to find f comma g and g comma f. Okay, which one? Well, we just said two, both of them. Okay, so if I want f comma g, always write the definition first so you don't make the mistake of plugging something else. So that's the first step. I have to write f comma g as f of g of x. I always said don't erase it like that, but why not? So just put in here a g, which is 3x squared plus x plus 4. Write it one more time, just for the sake of the argument. And now, obviously, you have to look at f. F says this. 1 minus itself. 1 minus this. So I write 1 minus, put parentheses, because I have 3 terms in there, and I don't want to forget to distribute to all 3 this negative sign. 3x squared plus x plus 4. And then I have 1 minus 3x squared minus x minus 4, and combine like terms the 1 with the negative 4. Is this better? So I would write this on the side, on scratch paper. I can do whatever I want on scratch paper, right? I can write any of my notes, so I don't forget. So this is negative 3x squared minus x and minus 3. Any questions on this? Okay, now the next one, the g comma f. I write the definition. Erase it if you want, if this helps you. Write it one more time. And now look at what g says. G of 1 minus x will be 3 of 1 minus x squared plus 1 minus x plus 4. Agreed with that? Okay, so then I write first 3 parentheses 1 minus x squared plus 1 minus x. There is no need of parentheses here. It's not wrong to put them. And plus 4. But now I cannot forget how to square binomial. Because that is the next step. I have, by the order of operations, I have to square this, then distribute 3, and then combine like terms. Is this better? You feeling a little bit better about this? Okay, so then 1 minus x squared, how many terms?
3.
Very good. Remember, this is the first thing I hit you with, because it's so important. Not to have to foil this over and over and over.
So it's negative x squared.
So remember, no, careful, careful. So we first term squared minus 2 times the first times the second plus the second term squared. And then minus x plus 5. I can combine these two. Now I distribute. So 3 minus 6x plus 3x squared minus x plus 5. Remember, you cannot distribute 3 before you square. I've seen it done. Please do not distribute because you have to square first by the order of operations and then distribute 3. So 3x squared minus 7x and plus 8. And this is the function composition G comp F. Is this okay? Okay. Are you okay? I have some cough drops if you need. So do we have other questions or can I make up my own now? Yes, please.
I was hoping
Right.
you could do an example of
Yes.
synthetic division.
Yes, of course. Yes. Any particular problem for us or? Okay, so let's say x to the fourth minus 3x squared plus 7x minus 1 divided by x plus 2. Can I apply synthetic division on this problem?
Yes, because the denominator is x.
Yes, yes. As long as the denominator is x minus a, not x squared minus a, not 5x minus 5. Although it is possible, but I have to factor out 5, and I did not show examples like that. I didn't see them in the book, so I did not.
So long as it's just x.
Just plain x, power 1, coefficient 1, and some plus or minus a number.
So what I pointed to on unity doesn't matter, right?
If the leading coefficient is negative?
No, I'm talking about
If it's x plus 2 or x minus 3, it doesn't matter. I just have to identify a correctly. Yes, it doesn't matter. It can be x minus 1, it can be x plus 3, it can be x minus 1/2. Yeah. So what goes in the box? Careful. So in the synthetic, do you remember that in the long division, right after we changed the sign? In the synthetic division, we changed the sign in A from the very beginning. So the denominator is x plus 2, and we have to compare it to x minus a. So then the denominator becomes this, and a becomes this. So that's why we write negative 2. If we had divided by x minus 3, I would have written 3. Because by comparison to x minus a is 3. Exactly like with a circle, exactly like with the vertex, the same idea. Okay, so negative 2. Now I have to make sure that the top and bottom, especially the top, is, in this case, in descending order. Is it?
Yes.
It is. So degree is 4. Degree 4 requires 5 terms. Degree 4, degree 3, degree 2, degree 1, degree 0. I don't have 5 terms. So I do have the leading coefficient, which is 1. I do not have the term with x cubed. I do have the term with x squared, 7, and negative 1. 5 terms because it's degree 4. 1, 2, 3, 4, 5. I'm degree 4. Degree 3 is not there. Degree 2, degree 1, degree 0. I bring down the leading coefficient. That's mandatory in synthetic division. I have to do that.
Question.
Yes?
You said when the exponent is 4 times.
When the power is 4, there are 5 terms. Yes. When the degree is 2, there are 3 terms. When the degree is 1, there are 2 terms. All is 1 more than the power. So negative 2 times 1 is negative 2. We perform the operations by adding 0 to negative 2. I get negative 2. Now negative 2 multiplied by negative 2 is positive 4, and I write it above the line. I perform the operations, I get 1. Negative 2 times 1 will be negative 2, and I write it above the line. I perform the operations I see, and I get 5. Final step, negative 10. Write it above the line, box it in, negative 11. So if I have 4 terms, what is the degree of this polynomial?
3.
Exactly. So I'm writing the answer here because I don't have space there. So what will be the 1 corresponding to which coefficient? With the coefficient to x cubed. That's what I meant. Thank you. Thank you, Marcus. Negative 2x squared plus x plus 5 minus 11 divided by x plus 2. The answer?
No. No. Well, if you want, that's fine.
Oh, yeah.
I missed the part where you started doing the multiplication. Because I see you don't multiply by the 1, correct?
So we first copy the
Okay.
leading coefficient.
That's what I meant. Okay.
Yeah, we copy the leading coefficient. That's the starting point.
Mhm.
Negative 2 times 1 is negative 2. 0 times negative 2 is 0 plus negative 2 is negative 2. Negative 2 times negative 2 is 4. Negative 3 plus 4 is 1. Negative 2 times 1 is negative 2. 7 minus 2 is 5. Negative 2 times 5 is negative 10, and when we add these, we get negative 11. This is the coefficient of, because there are 4 terms, coefficient of x to the third, or you can say, when I divide degree 4 by degree 1, I have to get degree 3. It's mandatory. X cubed minus 2x squared plus x plus 5 minus 11 over x plus 2.
I was wondering, X.
We divide degree 4 by degree 1. We have to start with degree 3. Or you say, oh, 4 terms, has to be degree 3. Now, is the long division okay? With the long division? Oh, we can do the same thing. Let's do the same thing. So we have x to the fourth, space, negative 3x squared plus 7x minus 1, and we divide by x plus 2. X times what is x to the fourth? Very good. I have to go back with x cubed, remember, and distribute, change the sign, and write below like terms. So x cubed times x. But I have to change the sign. X cubed times 2. It's 2x cubed, but I have to change the sign, and there is no like term with x cubed. That's why I have to write it under the empty space. Gone. Bring down the next in line, and bring down the next in line. Next question. X multiplied by what is negative 2x cubed? Now remember, at the top, we do not change signs. We are true to the top. Sign? Perfect. Negative 2x squared times x is negative 2x cubed, but I have to change the sign. Negative 2x squared times 2 is negative 4x squared, but I have to change the sign. Perform the operations I see and bring down the next in line. Next question. X times what is x squared? Sign? You understand that I cannot put x, right? We have to write a sign, a symbol. And it has to be positive. So x times x is x squared, subtract. X times 2 is 2x, subtract. Perform the operations I see and bring down the last one. This is the final question because now these have the same degree. It must be the last question. X times what is 5x? Sign? Very good. 5 times x is 5x, subtract. 5 times 2 is 10. And that's how we get the negative 11. And the quotient of x cubed minus 2x squared plus x plus 5 minus 11 over x plus 2. Remember, the long division works in all cases. The synthetic division doesn't. Okay, good. Other questions for me before I make up my own?
Wait,
Yes?
so you said that second one doesn't work with them?
Synthetic long division works for everything. Synthetic division does not. So see, the long division will work if this is x squared, but synthetic division will not. So synthetic division is good, especially for determining trying to see whether the denominator is a factor. So that might be a question for you. Is x plus 2 a factor of the numerator? Is x plus 2 a factor of the numerator? No. Why? Because there is a remainder. It will be a factor if the remainder were 0. But the remainder is not 0. So it cannot be a factor. Very good. Is there anything else that you would like to work on? Yes. Is there anything else that you would like to work on? Or can I make one up now? Okay. So I would like to look at a function. Let's say the square root of 2x minus 3. And I would like to find its inverse. How will we work on this? What do we have to do? Say it again. Yes, 4-step procedure. Awesome. So number one, first we replace f of x by y, and we know that that's allowed always because f of x and y are the same thing. Good. Then the next step would be,
Switch the x and y.
very good. Perfect. In step 3, solve for y. Excellent. But now I have to ask myself and dig deep because I've done this in chapter 1. So how do I solve this type of equation and what type is it? Not for you. So let's take a look. Before you decide what type of equation it is, just read it. Exactly. Once you say the square root, it has to be a square root, a radical equation. Good. Now let's think. Okay, how do I solve a radical equation? Of course. Get rid of the square root, of course. So this is x squared equals 2y minus 3. Very good. Awesome. And now, so move 3 first, and then divide by 2. I'm solving for y. So x squared plus 3 equals 2y, and y equals x squared plus 3 divided by 2. And this is our f inverse. I will also make a note to myself that I know that the quadratic function is 1-to-1 or not. It's not. This is a quadratic function, right? So under certain restrictions, right? Not on all domain. Not on all domain. We know that, right? So in other words, we have to go back and determine the domain from here and then reverse them. So if the problem is asking us, let's go back. So I have f of x, which is the square root of 2x minus 3. How do I find the domain of this function? We looked at 3 functions with it, or 4 already. How do I find the domain of this? What do I have to write on the side? Yes. Okay, I convinced one more student. That's awesome. Thank you, Joseph. So 2x going to 3, so x going to 3 halves. Okay. So the domain of this function is 3 halves to infinity. What is the range of this function? Imagine the graph of any radical. Even if it's stretched a little bit to the left, right, whatever, what is its range? Picture it. Picture the range of the square of x. From 0 to infinity, right? So then this function, I would like you to give me the domain and range for this one, for f inverse. Careful, just think and say, the domain of f inverse must be this, and the range of f inverse must be this. Remember, the function does this. From a to b, What does the inverse function do? From B to A. So look and say, the domain must be, not just the domain must be.
Infinity to 3 seconds.
Which one? I'm talking about the domain. What was it? What would be the domain?
Infinity to 3 over 2.
One more time. One more.
Negative infinity.
One more time. One more time.
3 over 2.
No. Wait. So the domain of the function is 3/2 infinity. The range is 0 to infinity. What is the domain of the inverse function?
0 to
Exactly.
0 to 3/2.
One more time. 3/2 to infinity takes to 0 to infinity. What does the inverse function do? Has to start here. It has to start here. So
0 to
here's
infinity.
exactly. That's why we determine these.
Yeah.
So it's the reversed. So that's why my note here. Not on all domain, only on 0 to infinity. Because remember, quadratic function is not 1 to 1. So I have to remove this part. Now it is 1 to 1. 0 to infinity. It is 1 to 1.
That's
Yes.
question.
Yes,
So
please.
this rule applies to all inverse functions, the domain. the range, and the
Always.
inverse.
Always. Always. That's why we're allowed to swap x with y. Because this value that is y for f becomes x for f inverse.
It's like when we have those problems where it's just the table values.
Yes. Exactly the same thing. Yes. Is that clear? Okay. Are we okay with the distance formula, the midpoint formula? Are we okay with the circle? Which one?
I don't believe everyone's okay with it.
Which one? Which?
All three. Let's do it for
So
Okay. So
Alright.
I had other problems in mind. I thought that these three formulas are fine, but let's say 0, -2, and 4, 3. The midpoint, we know it's the sum of x's divided by 2, and the sum of y's divided by 2.
So midpoint is
The sum of x's divided by 2, and then the sum of y's divided by 2. x1 plus x2 divided, everything divided by 2, comma, y1 plus y2 divided by 2. Okay, now the distance formula, always write it as x2 minus x1 squared plus y2 minus y1 squared. I recommend write the x and y's underneath if you want to use that method. So I have x2, which is 4. I have x1, which is 0. I have y2, which is 3. And I have y1, which is -2. I avoid nested parentheses if I do that. And I think it's easier to see. But you use your own method, please. So 4 minus 0 is clear. It's 4 squared is 16. 3 minus -2. 3 minus -2 will be 5. 5 squared is 25. So the distance is the square root of 41. Yes, please.
So in the, what's called my math lab, they would ask for first this.
And then the
this,
approximation.
and then, yeah, so.
I
how we're gonna
I
do
don't
this.
really care for, but if it's asking, you're just putting the calculator in. The square root of 41 is a prime number. I mean, 41 is a prime number. We can't simplify it. But if it were let's say the square root of 18, I would expect you to write 9 and 2, and write the square root of 9 times the square root of 2 is 3 the square root of 2. I would love to see that, yes. Thank you for asking. Okay, let's look at the
The square root of 18x, right? For you.
my math lab requires that. So this is the correct final form. This is the correct final form. Here there is nothing I can do. It's 41. 41 is a prime number. But with 18, I would separate it. Okay, so let's look at a circle, like x minus 3 squared plus y plus 7 squared equals 25. Is this a circle? So what is the center and what is the radius? And we will be asked to graph it.
-3, 7.
Careful. It's the same
Yes,
thing with the
it's
x minus, yes,
3 and then -7.
perfect,
And 5.
5. Do we know how to graph this? Do we know how to graph it?
Wait, where'd you get 5?
It's the square root of 25.
So the formula for the equation of the circle is x minus h squared plus y minus k squared equals the radius squared.
So the center would be 3 to the right,
Yes,
down 7.
yes,
There's your center, and then you go out equally 5.
5,